Okay, Lindsay, we are learning about power today. You can see the notes on the
Like
website.
horsepower?
But Marty's with us, so let's just hope for the best.
Like wattage and horsepower?
Yes. See, Marty, you remember the things.
I don't remember. There's no way I remember the formulas.
Right, do you have a horsepower?
Okay, so
You know horses actually have 15 horsepower.
yes, yeah. Mhm. I know
I'm
it's
serious.
it's kind of ridiculous. Okay, so power is like in physics we define it as the average rate at which work is done. The average rate at which work is done. Okay, so how do we calculate a rate? What is a rate? Yes, but like more basic than that.
Derivative.
No, more basic. Like really transport your mind into like 8th grade science.
Bruh.
Change divided by original. Whatever.
You're getting closer.
Change. Final over original.
It is. So okay, so
Final.
Why
wait, no,
why two
initial
why two over
minus-
why one?
a rate is something per time.
You right.
Yeah,
You right this time.
we overthink a lot of things.
That's true.
Okay, so if we've got change in work divided by change in time, what's another way of expressing work?
Flip back.
Work is
Kinetic energy,
kinetic energy
plus.
plus
Is usually like we can really abbreviate it mostly as the change in kinetic energy.
Oh, okay.
So delta KE divided by time. Now I'm going to drop the delta symbol from the time because we're just assuming that like at initial T initial is 0.
Okay.
So then like change in time would just be whatever time had been elapsed.
Sounds good.
Okay, so how do we calculate work then if we don't use kinetic energy? So what is the like
If we
base?
don't?
Yes, if we don't use this, there's another way of expressing work.
Bro.
Like in its very most simple form.
1/2 mass on the
No, that's kinetic energy.
Are we using potential then?
Nope. Like go back to the very beginnings of work. Work is the amount of force applied
force
over.
cosine s.
Yes, but even in its more basic form,
Just force.
times distance. Okay, so then that means that we can represent power in this way, but we can also represent power as force times distance divided by time.
That's what.
And then what is distance divided by time?
Velocity.
Yes. So then you can also express power as, I should have done this in a more linear fashion and I kind of hate myself. Also as power is equal to force times velocity.
No,
That's
we have the video,
fucking
so it all
crazy.
makes sense.
That's fucking crazy.
Okay, so
Okay,
now
Carter.
the trouble is that the SI unit for power, I'll use a different color here, maybe red. The unit for power is the watt,
Watt.
which is abbreviated also W.
Marty,
Okay, that. Okay.
what kind of
Okay,
what kind of watt? Marty, what kind of watt is your favorite?
Okay. Okay.
Probably like, what is it, like 1.21 gigawatts? From Back to the Future, Carter.
Oh, I thought that is not where I thought you were going. I thought you were going to the
Carter, I thought you were like a movie.
to the N-word watt.
Carter, you've never seen Back to the Future.
What?
Yeah, there's a
Mega,
like mega, but like nega watt.
there's one with an N too.
Yeah, nega.
Carter, you knew it.
Megawatt is a real thing. I thought
Yeah.
you were just saying megawatt like
No.
really fast.
No, it's the actual thing.
Oh.
Okay, so then
That's crazy.
That's crazy.
let's see. What do I want to tell you about work done by a variable force? Okay, this is also pretty simple. So I'm like section 6.8 is conservation of energy, and I don't think that we really need to talk about this real much because this is something that we spent a lot of time on in AP Chem. Energy cannot be created or destroyed.
Yeah, I know that.
And the reason is because energy is the conserved quantity. And
Well-
like, so it's like, we define it as something that's conserved to say that it is conserved. So it's kind of like a catch-22 of like circular logic.
Mark, you read that book.
But like all of the principles of physics are based on the fact that Carter, energy is conserved.
I conserve all of my energy, clearly.
Right.
So then power done by a variable force.
My favorite game.
Carter, what the hell? Did you hear him?
What did he
He
say?
said this is my favorite unit.
I love power done by a variable force.
Because it's 6'9".
No. I love power done by a variable force.
Let's be so real with each other.
That variable force is Martin.
What?
In unit 6-9, what's the power? What's the variable force that delivers the power?
Okay, so what do you think it means by a variable force? What do you think those words mean?
It's variable.
It's a force that we don't know yet. I
It's
don't know.
whatever force that you want it to
It's a
be.
force that varies.
It's like it's
Yep, I would say that that's probably.
like a force that is variable.
Wow.
And so because it varies, it's like non-predictable. And so in order to calculate power done by a variable force, you have to use graphical methods only.
No.
We won't actually end up doing that. I don't think that there are actually any problems on the AP test either, where you actually have to like use the graph. But the only way, if you don't have a linear force or even something that is of an x to the squared type nature, if you don't have a predictable curve, I mean, okay, like there's nothing else you can do but use a graph. So how would you do that? If you have distance on the bottom and your force on the y-axis, and like let's say your graph looks like this is the force over the distance, the way that you would use graphical methods is to calculate the area under this curve.
Ooh.
And the only way that you really can do that is by drawing a really nice graph and hoping for the best.
Of course.
So, not happening.
Probably not.
So that's why this is like I'm telling you about it, like this is how you could calculate it. But when you're applying power, you want there to be some sort of way that you can control what the output is so that this becomes obsolete.
And they think like that we know how to calculate the area under a curve.
Well, I mean,
Is that calculus?
yeah,
Not with
yeah.
the curve though.
But you like so you could calculate the area just by like, okay, so here's like 3.5 blocks, and then here's like 4 maybe and a half blocks,
Okay, it's
and
over, yeah.
Yeah, now you have to.
That's not happening.
so like that's how you could do it.
Yeah.
But that's why you don't want to try not to have this kind of output, so that
You don't have to do it.
that not becomes not necessary.
Alright.
Okay, so then homework 19.
Oh, we're at homework, yeah.
I know, there's not really much
Daniel.
here. Chapter 6, page, I don't know, because I didn't write it down. 62 through 69.
Okay. Well, this chapter is really great for.
Carter is having a great day. And then 70 you can do for extra credit. I know that this is a lot more problems than I normally assign you. 1, 2, 3, 4, 5, 6, 7. I did 7 of them on one page.
Oh man. Okay.
Here's my work.
I think there's only
There's 8, I think.
four, 6, 3, 6, 4, 6, 5, 6, 7.
My number 70 though, that's the extra credit one, is this whole thing here.
Okay, so that's not happening.
It's just it's a force diagram, or I mean it's a free body diagram one, and it's not as bad. It's not as bad as it seems, and it's pretty satisfying to get to the right answer. So if you felt like, oh, I need a mind tickler.
No,
A mind
I never-
tickler for you.
I don't really ever need a mind tickler. you know?
Okay, so then to recap what we're gonna do for the rest of this week, we are going to almost.
Do a what?
On Wednesday we'll do a little lab that I have for you. You can look on the class website and see that. On Friday we're gonna have an MCQ FRQ party, like we did last week.
Good.
And then the week after we've got 2 days, and then we've got like 2.5 days after that. So
That's scary.
Mar, do you have the McDonald's app? 'Cause
I
there's
think-
McDelivery in the app,
McDelivery.
and then you can use.
is that what it's called?
It's called McDelivery.
I mean, everything's
There's a bunch
right?
of deals, Mar. There's like you can get like 30% off.
McNuggets.
Like I think daily deals there's like 30% off.
Okay, let me just look on here real quick.
Free 2 small or medium fries with purchase on your nugget. Free large fry.
Oh yeah.
$0 delivery fee.
ooh.
Minimum purchase $15.
Yeah, we are a little bit ahead. So I think what we're going to do is we'll take our Unit 4 exam
Friday.
the week before finals week.
Oh, bet.
Okay.
Sounds good. No, that's great.
And then we're actually like 3 days ahead. And then we can do some stuff. We can do some like AP test review.
Yeah.
Instead of like just having 2.5 days of work days, we can do some AP test review. And then like take it easy a little bit because you'll have exams for everything else.
I am not
So because
against-
there's only 2 of you and we can plow through all of this material in 11 minutes,
Real.
we might as well.
I plowed through. Well, actually, most of my exams are getting moved to like the week before. Our
Yeah.
English one got moved.
Well, and I think last year because we had that snow day to end the semester, I think that
Everybody's getting scared.
you might as well
Yeah.
if you can
What
manage.
else? What else is there? I know theology will be wrong.
So if you have questions about these homeworks, just
Math is the week.
let me know. But
before.
if you have questions, it's probably because you're
No,
overthinking.
math is not.
They're pretty easy.
Gym final